Hello, everybody. My name is Gurvinder Ahluwalia. I'm the founder and CEO of Digital Twin Labs based in Dallas, Texas, in the US. I'm so glad and privileged to join the India Mobile Congress and the vibrant community over here. And what I'd like to discuss with you is today what I'm calling a tryst with technology. And being that this is an Indian audience, I'm sure you understand the inspiration of that title. And in some sense, it is quite literally that on how the changes of technology are bringing us in such entrenched manner, not just for business processes, but in social behavior and social contracts. So specifically, what I'll focus on are three technologies, and that is blockchain, AI, and IoT. I will emphasize a little bit more on the blockchain side because I'm making an assumption that is, even though there is a lot of buzz around it, but I want to unpack some of its fundamentals and, more importantly, its technical, business, and as well as social implications. AI and IoT are, of course, much wider understood, so I'll spend a little bit less time on that, but I will want to also make the connection, the intersection between those three things. And given where I'm situated and where I spent my career before I finished my undergrad in Delhi, actually, I will be bringing a global perspective. Just to introduce myself, I previously was the Chief Technology Officer for IBM North America, covering blockchain, IoT, and cloud. So no surprise that those are my areas of deep expertise. Of course, I will be speaking from a non-technology, non-product, non-vendor perspective. And currently, of course, I am in a role of neutrality in stewarding the industry, not product-centrically, but solution-centrically, with the impact to business and with impact for societal good. So with those remarks, I'll also weave in a few of my experiences in the field on what we do in the context of some of my messages that we'll talk about over here. So let me go back real quick to what was the dawn of the internet, or what preceded the internet. So from the humble beginnings, the internet is not just a modern technology wonder. It has actually challenged human agency over data trust and social change. And that is something we have felt acutely over the world in recent years. I'm talking about social networks, and I'm talking about authenticity or lack thereof of information. So if you look at the chart on the left side, the internet, or the ARPANET back then, really started as four nodes at the University of California, LA, University of California, Santa Barbara, the Stanford Research Institute in the Bay Area, and the University of Utah. Now, of course, I'd be preaching to the choir if I try to tell you the complexity of where the internet is today, which is what the picture on the right side tries to depict, of 50 billion devices by most projections, or actually that's where we are in 2020. I hope that is an actual number and no longer a projection. And it's also remarkable, even though there's been such a drastic change in complexity over here, and no longer just a technology, but an actual social shift. The first three letters that were transmitted on the original internet were LOL. And the transmission was actually for the word login. And they typed in LO, and the ARPANET crashed. They took an hour to bring it back. And then they typed in the rest of they had to retype the rest of the string. So if you look at it that way, the first three letters that actually transmitted ever on the internet were LOL, and that's quite a bit of what we are doing and our children will continue to do. So let's look a little bit further now, moving from the technology side to the dimension of the firm and how companies have been changed as a result of the underlying plumbing that has innovated. What I mean by that is that we had and we still do have conglomerates. We have companies structured as corporations, and then they reorganized as business units focusing on their core competencies in the 90s, which is around the time when I started my career. And then we came to the dawn of the World Wide Web, and that's when companies started forming as value webs, and certain ecosystems started to take place. And it is actually around that time when India became a major participant, in fact, a major influencer in global business and the shift of information technology to India as a part of the connectivity that became available. So value webs is how most companies and ecosystems and the industry is situated today. So if we project, in some sense, not just project, but where we are now, is the formation of decentralized networks. And I would see that these formation of decentralized networks in this portfolio will continue to take stronger foothold and more adoption. The last box on the right side of this spectrum and progression that I provide is really where business and interaction between ecosystem players is moving towards autonomous behavior. And this is not necessarily just people and just company and just digital information. It is also the movement of physical things and the autonomous movement in the IoT space. So you begin to see the connection that I'm drawing over here, which is at least two aspects, actually all three aspects of the highlights of my talk, which is blockchain, IoT, and AI. So the autonomous portion comes from AI. The decentralized network is the representation of blockchain underlying technologies. And then, of course, I alluded a little bit to IoT. The last point I'll make is the takeaway at the bottom of the slide over here. And the challenge, this picture also, not just the progression, but it also depicts the challenge that we are faced with and why there is going to be, why we are in a tryst with technology, frontier technology. And that is because the complexity to manage today's value webs far exceeds the advantages for which they were originally built. They've served their purpose very well, but now it is a time to add to the portfolio. Also, I would clarify that I'm not talking about a complete supplanting of the previous topologies and previous firm structures, but I'm talking about an addition to the portfolio of decentralized networks and then moving on to autonomous networks. So a new future is demanded. A new behavior must emerge as a result of the wheels beginning to shake on current structures and current interactions, as we are all seeing. Let me give you the third dimension over here. So I gave you kind of the technology progression. I gave you the firm structural progression, tracking in line with technology. And I'm going to give you the economic grounding on why this expectation for a tryst with technology will happen, and is already happening. Technology really does not explain disruption. We commonly associate technology to be the disruptor. The disruption is really explained. Disruption is really a change in behavior, and behavior is really explained by economics. Now, I'm a computer scientist by my training, so I have really no expertise in economics, but I do lean in the recent years. I have leaned on understanding some of these fundamental economic literatures to try to explain what I'm headed to tell you. So the structure of the firm is the way I was describing it previously was based on transaction cost. And the father of transaction cost theory and the theory of the firm is Ronald Coase. Ronald, and by the way, the books on the left and the right are, the authors on the left and the right are Nobel Prize winners in economics during their times. Coase's work was done around the 1940s. He wasn't recognized for the Nobel Prize until, I believe, the 1970s. And that also is noteworthy on how long it sometimes takes to recognize drastic shifts and drastic impacts of new discoveries and new theories. And the idea being that that firm structures are based on transaction cost. So if a firm wants to lower its transaction costs, um, it finds lower transaction costs by external relationships with external entities and partners, it'll engage with in-value webs. If it finds a transaction cost to be lower by taking that function within the firm, then it'll keep that function within the firm, and there wouldn't be a need for that vector in the value web. So it describes the contraction, it explains the contraction and expansion of firms based on transaction costs for the function that it needs to do. And the point from the technology dimension over here is that those transaction costs and those transactions with other entities on the value web happen on the underlying plumbing and substructure of technology. If we look at the work done in the middle by a professor from Argentina, Carlota Perez, I'll be brief in her explanation. Her point is that disruptions not only happen, but they're actually predictable. Disruption cycles are actually predictable. There's far more elaboration to her work that I can't do justice, but let me jump to the next one, which is Doug North, and actually the most recent of these three. And he got a Nobel Prize, I believe, earlier this decade. And his point is very, very fundamental over here. And his main message from this work is that you do not need organizations in order to organize. Let me repeat that. You do not need organizations in order to organize. What that means is that the importance of the entity is less than the importance of the function the entity delivers. So if you can find alternative ways to deliver the function, that is what will excel, endure, and succeed, as opposed to the entity. Now, we've seen that, let me give you an example, quite a bit in banking. Banks have not gone away, right? Banking has not gone away, even though banks have been reduced, right? Number of bank facilities, branches or something. And then you do mobile banking. So it's the importance of the function, not so much the importance of the physical entity. So with that, let me come to the elements of what I'm calling the TRYST with technology. And there are actually numerous participants, as you can see on this slide. Of course, 5G is the heartbeat of the conference. Cloud, everybody knows, AR, VR, a lot of activity over there. 3D printing, the fourth industrial revolution, quantum computing. But the ones on the left is what I really will focus on, starting with blockchain, and then I'll do a light touch to AI and to IoT. If we look at this progression, harkening back to the ARPANET slide that I had, what we built out very well is the Internet of Connectivity. I actually take a lot of pride and privilege in starting my career by designing and deploying the second largest commercial TCP/IP network of the world around the mid-90s. Incidentally, that was for Motorola, which was the king of the hill at that time. And we did a very good job, the industry did a very good job in building out the Internet of Connectivity, which then progressed into the Internet of Information and Web, which is, of course, the main incumbency that we have today. And after that, there really has not been a massive infrastructural innovation. There's been a lot of application level innovation, but not infrastructural innovation. Yes, there has been infrastructural innovation on the cellular network side, but not on the internet side. And on the existing Internet of Connectivity and the Internet of Web, on top of that, we repurposed the Internet of Voice over IP, tying it to this to mobility and the core of this conference. On top of that, we also repurposed the Internet of Locations and maps and GPSs. And incidentally, there is also the Internet of Food. We've also, in my company, been doing some work in the tracking and tracing, what I prefer actually to call provenance of food and nutrition, And there is actually something called the Internet of Food, which is being put together. So in this journey, we forgot to build an Internet of Trust. And that is the gap, and that is the role that blockchain is trying to bring that piece of the puzzle into this larger picture. That is not a good or a bad, but there was no expectation when ARPANET was first done by those 4 nodes, and even when TCP/IP came, quite frankly, even when the web was invented by Tim Berners-Lee, there really wasn't any expectation that there would be properties of the size of Facebook and Google, so on and so forth, and the kind of applications and commerce and vibrance that's happened. None of that was anticipated. So it's not a good or bad statement, but it is a statement of fact that we did not build the Internet of Trust, and that is trust in data, trust in transfers, trust in privacy, trust in sharing, trust in doing changes and updates to software or other forms of content, trust in ownership, trust in identity, so on and so forth. I'll recap some of those messages in a later slide. So now you ask me, what is the definition of blockchain? So I can't leave you without that. Here's the definition that we've put together. A blockchain is a decentralized, distributed, and immutable digital ledger that is used to record transactions across many nodes. So in the left side of the picture is the traditional network ecosystem, and the icons being different shapes really signify that those are different copies of their individual databases, as opposed to the right side where they are all circles for the participating members of the ecosystem or the node in this blockchain network. And given that they are all circles, what it means is that everybody has a replica of the same database, right? Instead of having their own individual database or their own individual record or ledger of something, they have one common ledger, just like a bank. They have one common ledger, they have one common database, and they have a single source of truth. Everybody has a replica, and everybody has it available almost immediately once a change happens into the network, right? So let me just move to the next slide, and I'll go through this one a little bit faster. It unpacks, every word in this is religious. And I'll just sample a few of them without going through the detail. When I say transactions, it means a change in state, the one in orange, number 6. A blockchain is specifically called out that way because it's not, bottom left over here, is not the blockchain. There will be numerous blockchains. The entire world is not going to exist on one blockchain. Then if you look at the green one, ledger, there are agreed checks and balances between parties, and only when the parties come to consensus is the transaction written out to the database, and then it's replicated to all the other nodes and participants. Then I'll point out the last one, which is nodes. Nodes is about representing a participant, and a node is a replica of the data. Actually, let me also point out decentralized and distributed, especially to those of you who are technical. That's, of course, a technical phrase or 2 words, and it reflects topology, but it also reflects control, and that's why I wanted to make this point. And it also reflects fairness and governance of the blockchain network. So what I was alluding to previously is in a more complete slide over here, and that is, blockchains matter because trust matters. Trust matters because ownership matters. Land ownership, which we all know is a problem in India. Honduras was the first country which used blockchain for land ownership, home ownership, identity, decentralized identity. The Syrian refugee camps became to the size of like 30,000 refugees, which is almost like a small little town, and supply of rations, including crime, all those things had to be managed. And the identity of the refugees over there was actually handled through a blockchain network. Authenticity is important. The provenance of pharma. Think of drugs, particularly these days. Think of food supply chains. Um, I want to know the provenance, who has touched it, where has it been, how long, under what kind of environmental conditions. All that is logged immutably in the blockchain. So authenticity matters. Provenance is what I just used. Timestamps, change. I want to distribute content. I want to update cell phones. Right now, most providers, I think, are doing it in a centralized manner and throttling things up and down. But what if we can do decentralized distribution of content? Tracking of nutrition for compliance purposes and other purposes is also actually some work that we've been doing with certain philanthropic and other United Nations kind of institutions. Let me do a touch on AI, with that being the blockchain explanations. And the way I describe it is, let's look at the progression of systems build out that the industry has invested in significantly over the last 80 years, probably, starting with tabulation. I pointed in my introduction that I used to work for IBM, where I was the chief technology officer for blockchain, IoT, and cloud. This is also the era where IBM started. It was a tabulating machine. It was producing tabulating machines. And systems then were focusing on automation. After that, started focusing on automation. And that's when the world went through, I would say, for the most part of the 80s, 90s. And then in 90s, the realization came that, yeah, I've automated this, but if I have to change something, it just breaks. These systems, yeah, they automated, they work very fast, but they become very brittle. So then the emphasis shifted to building systems out that are able to accommodate change. That's when you started hearing object-oriented, agile, modular architectures, layered architectures, so on and so forth. You started hearing service-oriented architectures, and a lot of those legacies are what culminated into the perfect storm to create cloud computing services, by the way. So they are still very foundational. And now where we are is building out systems that learn. Increasingly, business and societal trust and reliance is on this system, and therefore also the data has to be trusted. Let me tie a similar parallel progression which led to blockchain networks. We started with centralized systems, and mind you, those have not gone away. They've shrunk in their footprint, but they still exist at the back of airline ticketing systems, most financial systems, banking systems, national intelligence systems, are mainframes. And then we moved into transaction systems becoming web and mobile-based transaction systems. This is the world of Amazon, of eBay, of PayPal, of Flipkart, of Alibaba, so on and so forth. This is the current world of most computing on how it's done. This is the world of e-commerce. This is the world on which 3G rode, 4G rode, and now 5G is getting ready to ride. And then we are on to decentralized networks. And that is the third generation of transaction systems, right? So you think of blockchain as the future transaction system. So this shift in topology, but it's also a shift, as I was pointing out earlier, in control and governance. So the idea of learning, of the advancement in learning systems, is beautiful, but it's only very good and will be successful if those learning systems can trust the underlying data. And the trust in the underlying data is going to come from what is also called the trust engine, or from blockchain protocols and blockchain networks. If you look on the right side, I've got a list of use cases. I've actually been doing some work. I co-convened what's called the COVID Credentials Initiative, which started out a totally volunteer community, and we thought it would take about we'll get about 40, 50 people. At the kickoff meeting, we had 200 people, and then I think it's now up to about 400, 500 people from all over the world, including India, I might say. And that is to use blockchain, specifically use something called digital identity or self-sovereign identity for reporting, for sharing infection status. The second example is around a short chain of custody. A semiconductor components go around the world 25,000 miles before those components and that IC, integrated chip, goes into an OEM manufacturing assembly like a TV or a radio or set-top box or whatever it is. So how do I assure who has touched it and where it's coming from, the components in that IC? Supply chain and logistics. If I'm in the business of diamond, and there have been some bank failures because of double spend in the diamond industry from India, many of you would know that. And that is because the inventory and the transparency in supply chain of high value assets like diamonds is not there, is not sufficient. So for that reason, banks have failed. Digital Twin Labs, my company, partnered with one of the largest tier 1 consulting companies to implement a blockchain-based network for the supply chain and trade of diamonds for one of the largest diamond manufacturing as well as retail entities. Trade finance. So as things move through the supply chain, the status of that movement are important triggers to the banks, which are providing not just the movement of the physical goods, but also the transaction that I've been able to lock in a purchase order. I can now get a line of credit, and those can be and then I've loaded something. I've got a bill of lading. I've delivered something, and all those result in release of payments. So the eventing between logistics and supply chain blockchains on the one hand, and trade finance blockchains is really important, and that will release in assured manner the payments based on transparency and assured status of the underlying physical good of movement. So you begin to see the connection of blockchain and IoT over there as well. Anti-counterfeiting, jump to the last one, for aerospace parts, for automotive parts, including for diamonds, as well as for pharma. There are a lot of counterfeit drugs in the industry. So there are a lot of use cases over here. Let me just move on to the last couple of slides and then begin to wrap up. Excuse me. Been just recovering from under the weather. So we hear of IoT, we hear of systems that are programmable and autonomous. If you have something simplistic where you have only a few devices, then it's quite simple in doing the calculations. If you go into a little bit larger, what traditionally is being called the Internet of Things, you can still do some calculations. If you go into smarter connectivity, not just connectivity, but smarter interactions between things, it becomes too complex in order to compute it. Traditional algorithms cannot compute it. And that's because the permutations and combinations are just infinite. So that's when you get into learning systems. The example on the right side is autonomous driving. And there is just no way to figure out all the permutations and combinations that a vehicle would get into in order to be able to calculate it. So that's where learning systems are used. So the IoT connection with AI is really important over here. The bullets at the bottom highlight where data, as we all know how important that is, and its connection with blockchain. You understand that now. IoT is a major source of data intake. IoT actually is producing 6 times more data than social networks. A modern car generates 1 gigabyte of per hour of data, and an autonomous car generates 350 gigabytes per hour. I'm going to skip this slide in the interest of time, and I'm going to use my last wrap-up slide over here, and my timer is going off. So the main takeaways that I want to leave, or the agenda for our TRYST with technology, are the following. Number one, IoT is digitizing the physical world. It's providing the connection between atoms and bits, as many of you might have heard that description. AI is serving prediction. I wouldn't characterize AI for automation, because it really is after prediction. And then based on that prediction, you can have autonomous behavior. And autonomous behavior is not just about vehicles, it's also about robots and other entities. Also, let me just take a moment. I think this will be very, very interesting to you. If you think about global container shipping, today we tell the container where to go. Tomorrow, the container is going to tell us where it wants to go based on all the calculations it's done. Now, granted, the human being would have a override kill switch to make any adjustments to it. But autonomous behavior is not just about mobility. It's not just about what we think of traditional mobility and automotive. It's also for things that otherwise need to be put in motion, like containers in global shipping business. And blockchain is the trust engine for data and to produce liquid marketplaces. I just threw a term over here which has far more elaboration than we are able to do right now. But it's basically the implications to the commercial part of enabling transactions and incentives and participation of entities in blockchain ecosystems. The second takeaway is that blockchain changes behavior, actually elaborating a little bit on what I just said. The way to understand blockchain is really not as a technology, but that it has intrinsic mechanisms for governance and incentives. And if any of you are excited about understanding that more, message me on LinkedIn or Twitter, or otherwise email me. To change the world, as I say, if you want to change the world, you have to change the incentive. And that hooks into a little bit into the previous point, which is how do we provide the incentives? So the aspect of trust and incentives, when I was saying we didn't build the internet of trust, incentive probably is one of the elements which drives participation, but then also trusted participation. So to change the world, you have to change the incentive. And then the last point I would leave you with is our TRYST with technology invents new business behaviors and social contracts. I will emphasize that it's not just about the technology, it's about the larger, the second order impact, the third order impact, reaching into society and other institutions that are equally important. In fact, those are the ones that are becoming a little bit challenging these days, and we need to address this not just by the technologists, but by transdisciplinary activities. So thank you so much. I've enjoyed, and it's been a privilege sharing my thoughts as a keynote to you. I hope you enjoy the rest of the conference, and wish for you and your family's wellness in the times, and make the best of the holidays. And a very, very happy New Year to everybody in advance. Thank you so much. Bye-bye.